the company Iridian is a Canadian supplier of the custom optical filters and coating solutions. So Iridian, our company now have about 160 staff providing the extensive technical expertise in all areas of the thin film manufacturing. So the company is the private company, which is established in 1998. And we have all manufacturing done in Ottawa, Ontario, Canada. Iridian has achieved the ISO 9001:2015 certification in the middle of in May of 2016, and we also registered in Canada Controlled Goods Program. Our facility was finished in November 2015 with about 45,000 square foot. We designed and manufactured thin film dielectric filters and coatings. So our capability is the wavelengths. If we talk about wavelength range, it could be starting from 300 nanometer to 15 micron. All customized solutions. We can do the single, multiband, and multi-zone filters with the dimension of smaller than 1 square millimeter to larger than 150 millimeter diameter. So our technology is energetic sputtering and evaporations, and we have more than 20 coating machines. We do custom design, controlled software, and we have the in-house partnering by photolithography. All right, so today I'm mainly talking about the telecom filters. We said today's telecom filters. So Iridian is the world leader of telecom filters in the long-haul, X-core, metro, and access market. The WDM in telecordia channels, the dual-band filters for the wireless backbone, and gain flattening filters, and all other telecom filters. So let's review the picture of the basic optical fiber optical communication system. So our filters can involve in the whole system, starting from the light source to the multiplexing devices, and go to the fiber. Of course, the fiber need the gain amplifier, the gain amplification. So the gain amplification device need the gain flattening filters. And go to the receiving side, and the demultiplexing device also need our filters and to separate the wavelength channels through the detection. WDM channel skip filter, that's the first topic I'm talking about. So the channel skip filter are the components added to the wavelength division multiplexing, including the WDM add and drop module in the CWDM and the DWDM applications. To this one, and to facilitate the band split and to manage the triple and manage the multiple ITU channels. So these filters features very narrow transition from the passband to the blocking band. So minimize the lost channels while maintaining the high spectrum efficiency, since the express channels undergo only one refraction. All right, so WDM channel skip filters design, we have CWDM skip filter and the DWDM skip filter. So CWDM skip filter, it's relatively simple. Usually we only have 2 skip 0 and 4 skip 0 configuration. The DWDM skip filter, they have a more type of the filter choice. So we can see the channel wavelengths from the wavelength multiplexing signal, and we can choose the 2 channel, 3, 4, 5, and up till 16 channels. And skip channel depends on the application and the design requirement. It could be 0 or 1 or 2. All right, so let's take a sample of a 4 skip 0 filter work. So this is the graphic is a typical 1 input 16 output DWDM module. So if we're using the 1 channel skip filter, for example, a 4 skip 0 filter, then can group the 3 different bands, allow 1 band to pass and reflecting the other 2 bands. So if we're using the 3-4 skip 0 filter in this module, then can to make the 4 channel groups. So we can see the 4 groups on the graph. Thus, the final channel, the channel number 16, only accumulate only 4 channels worth to insertion loss. If we don't use this skip 0 filters, then we will have the 6 channels loss experienced using the, well, if we know this skip filter, if we only use the individual passband filter. And skip filter on the cost performance analysis. The telecom infrastructure budgets the real or opening network requirements generally are the inflexible. So designer must be balance the cost versus the performance when integrating the channel skip filters. The first consideration is the number of channel X. A skip filter covers how many filters will be necessary, right? So designer must be think about use the 8 skip 0 filter or 4 skip 0 filters. So while the 8 skip 0 filters has the higher cost than 4 skip 0 filters, but less 8 skip 0 filters would be required for the application. So this is the choice need to be balanced. Then let's see the details how to make the choice. So the consideration also the performance based built around how many channels will be allowed per filter while maintaining the module's necessary performance. In 8 channels accumulated insertion loss acceptable, or 4 channel accumulated insertion loss acceptable for me. So designer might consider the skip 1 filter also. For example, utilize the 8 skip 1 filter would lost the total from the 9 channels lost 1 channel. So calculation is about 11% of the network capacity across those channels. And so in the trade-off this application, a lower component cost will be. That means the skip 1 filter will be actually it's much lower cost than skip 0 filters. So the skip 0 filters allow to regain those lost channels, but they have to increase the component cost for sure. All right, so the decision to this decision could be more critical for the long haul application because it's high efficiency carriers are more significant when the marine cable in the bottom of the ocean and may also already be sunk, and also the underground cable in the land. The cable is already installed. But in the local application, it might be more cost effective to just simply add more fibers. So how do we help you? So nearly every application demands to the customizations to ensure the optimal price-performance balance. For example, if we have the two customers both require the A-skip0 filters that cover the same channels, but they have the different need for the wavelength range being blocked, the pass bandwidth, the refract bandwidth, the transmissions, and the reflection isolation. Thus, the standard off-the-shelf, the stock filter, maybe it's not meet customer needs. So, our design in the customer channel skip filter, and we can use our experience to meet the need of the countless customer with the similar needs for use. When discussing the channel skip filters design, so merely denote that the two things to the definitely different. So with the skip0 filter, increase the stiffness, then we talk about they can quickly drive up the filter cost. So the customer whose application, if permitted for more relaxed roll off the filter response for the frequency changes can reduce the cost by ordering the filter, or combination of the filter customized to that need. So we have to understand what the customer really need, and cost efficient and performance important, whatever we have to think about. Okay, so next thing we need to talk about is the multiband pass filter. In currently the WDM and the PON module design, the single band filters and the multiband filters are used for the same purpose, to permit to the filter is permit to the narrow wavelength range to pass through and reject the wavelengths outside that range. The multiband filters are used to transmit two or more bands. It can be 3 or 4 bands. Those bands can be a wider bandwidth or narrow bandwidth, or can be the standard CWDM channel bandwidth. So they are separating them from the other band and replacing the 2 or more single band filters, single pass band filters. And that one we can build it in the single component. So we don't just fill the available space, we also need to optimize it. Iridian recognized the market need for such components to enable and improve the long-term evolution, LTE. Also, sometimes people call it the 4G wireless transmissions. Now, the fast forward to today's market need the multi-band filters driven by the technology's demands in modern 5G wireless transmissions, from the middle wave band to the millimeter wave band. We're shrinking the consumer devices and increase the connectivities in the numerous technologies, include the military, consumer, and medical devices. The most popular application for the multi-band filter currently is the wireless station interconnection for 4G, LTE, and 5G systems. So the multi-band filters also can be used in the NEC-WDM system, where the minimize the component count to reduce the component footprint is an advantageous. For example, it's used in the GPON, NGPON, the GPON, XGPON, and XGS-PON, which leverage the 3 specific wavelength channels, say the 1310, 1490, and the 1550 nanometer. Let's see how the multiband filter performing. If we take a look at the spectrum graphic, So this is the typical CWDM 3 triple band. We call it triple band filter, include the channel 1320, 1450, 1550 nanometer. If we make additional band, that additional band makes on the filter do not encourage any performance degradation. So multiband filters are capable to produce the flat passband and good reflectance, isolation, and almost all used cases. So the channel spacing must remain reasonable, and the deadband must not to be too steep. For example, we can say, well, 20 nanometer is the achievable band space between passband and passband. But if you can do the 50 nanometer or 60 nanometer between adjacent passband channel, it will be more preferable. Otherwise, if the two passband are too close to each other, it will make the filter like a narrow notch filter. So assuming the specification requirements are similar, the total cost for the single band filter and the dual band filters are comparable. So what means of the comparable? We can say on average, if the multiband filters, it could be a little bit more expensive than the single band filters, but it should be less than 20% higher than the single band channels in the cost. But the performance is still the fit. So that's the advantage of the multiband filter we consider about. All right, so multiband filters, we can save the fiber connection. The advantage for the designer is to reduction in the overall footprint for the equipment closet, or we say the module house. It's used to install the wireless interconnected station, which becomes the more critical as the number of the stations increase the 5G network and cost of the urban real estate score. The system performance is improved by using MBPFs. It's reduced the number of the components within the module and optimize the use of the space, dimensions, and designs in the specified by the removing the number of the fiber connections to reduce the insertion loss. That's the purpose. All right, so Iridian's experience is designing in the other area carriers over into the design of the dual pass filter too. The result of the company's diverse range of the capabilities allows us to produce the component on the most difficult specifications. The variety of the specification in dual pass filters is required by our customers in expensive, required the deep knowledge based and based on the tackle. So this is the sample of Iridian's dual pass filter in PON application. Right. So the channel spacing is the key point we talk about. The channel spacing is very important in the multiband filters design. In the NG PON, we can see the table, the number 3 NG PON. They require the two passband very close to one another. For this design, the central wavelength is the central wavelength of these two passband is 1545 and 1600, or sometimes 1610. So let's see these two spectrum. So the first one is the XG PON dual pass filters. This one can features very wide operating wavelength range with the deep isolation in reflection band between the two passband, right? and also very low ripples in the passband. Very good performance. The second one is the NG-PON, the dual pass filter. And they have the two passbands close to each other, like a notch filter. So, but the performance is still good. But of course, the isolation between two passbands cannot be as deep as the first one. This is some specialized multiband filters design, which is showing the customer to see. The first one, we are starting to the 100 gig DWDM dual pass filter, but some limitation on the design. We can see from the spectrum, it allowed to pass two DWDM channel and refract in the middle. And the second one we designed for, we call this a half-band CWDM multi-band channel. And from the spectrum, we can see total about 9 passband. Every one is the half CWDM channel. Iridian can do the very high volume supplying for all different multiband filters. So we designed and manufactured the optimized price performance balance, particularly in WDM, the PON module. We can achieve the customer design, prototype, and produce the dual pass filters and triple pass filter, quad pass filters, and consistent quantity and super performance in this range, ensuring the stable high volume supply. Next one, I will introduce the hybrid gain flattening filter. So the beginning, let's review what is the gain flattening filter. So the gain flattening filter is used to flatten or smooth out the unequal signal intensity over a number of the specified channels in C-band, L-band, and U-band. And this unequal signal intensity usually it's occurred after an amplification stage. So the amplifier could be the EDFA and or Raman amplifier. So what is the hybrid GFF flattening filter? What is the hybrid gain flattening filter? So the filter which combine the functionality of both WDM and the gain flattening filters in the one component, or for us it's said in the one filter. That is the hybrid GFF. Alright, so how GFF and the WDM filters serve the optical filter amplifier. Let's see the EDFA module used to use and urban doped fiber to eliminate the need of the transfer from the signal from the optical to electrical and transfer the back. So this is we call this the passive amplifier. It's not like the electrical amplifier, it's active amplifier. And the optical signal is is amplified within the fiber by the laser operating at the wavelengths of 980 nanometer or 1480 nanometer, used to excite the urban atoms, to emit the large number of the photons when triggered by the much weaker incoming optical signal at the same wavelengths as the incoming signal. So most telecom wavelengths operate in the C-band or L-band, while now sometimes it's also in S-band. And the pump laser acting upon the signal will disrupt these precise wavelengths, particularly the problematical in the fiber accept the multiple channels. In the traditional EDFA module, a filter is used to flatten or even out the outgoing amplified signal. And we already talked about these filters operating in the tandem within the 980 or 1480 wavelength blocking filter. So to this one, to minimize the interference caused by the pump laser in these two wavelengths. Then the hybrid GFF can combine the functionality of the both WDM and the GFF on the one component. Especially the hybrid GFF can block the pump laser. We said the pump laser on the wavelengths of 980 and 1480, and while still providing the gate flattening for the signal light amplification. So without the need for the additional pump wavelength block filter like the WDM filters. So hybrid GFF can be designed to pass or block so other wavelengths also. Sometimes the people not only want to block the pump laser 980, 1480 wavelengths, but they want to choose some wavelengths between the 900 nanometer to 700 nanometer range. We choose the one range of the wavelengths need to be blocked. We can do that also. And let's see what is the advantage of the hybrid GFF can offer. So neither the base GFF nor the WDM is a trivial component. So combine them into a single component that costs less than two separate filters. Well, this filter is it's not cheaper than each WDM or GFF filter, but if we think to combine these two filters together, the cost will be lower than the separate two filters. Right. So this is the advantage. The benefit of Iridian's hybrid GFF is substantial the cost saving in cost vary more than a base GFF while offering the functionality, the two components. In addition to eliminating the cost of the separate filter, use of the hybrid GFF system designer can system design the complexity by cutting out the unnecessary component. Simply says the two components combined to the one component. And also lead to the more compact dimensions for the EDFA and other optical amplifier, whether you are trying to reduce the equipment size and accomplish to provide more within the same space. All right, so in terms of the quantifiable of a performance metrics, so Iridian's hybrid GFF is doing excellent as well. The GFF performance is defined primarily by the spec of peak-to-peak error function. Iridian already knows as to produce the base GFFs with extremely low GFF, very good performance on the GFF. So as with the base GFF, we can say the deeper the modulation depths, the more difficult it becomes to meet the customer designed peak-peak error function. So there is no performance compromise when the upgrading from a base GFF to hybrid GFF. That means we can make the hybrid GFF the same performance as the single GFF. So we can summarize for the hybrid GFFs in the capacity, performance, customization, and optimization. So the capability, we can support the new system design to new system designer to take the better advantage of hybrid GFF, given the qualification cycle necessary to effectively launch a new technology or a new system in the field. In the performance, the system designer can implement the net performance gain when when opting for the hybrid GFF. So over a two filter setup to eliminate the insertion loss between the two filters. Customizations. The given batch of the EDFA will be produced from the spool of the Iridian doped fiber. So they have the specific gain profile. The GFF must be designed to match that profile. So this filter specification will be effective so long as the same drawing of the EDF, the Iridian doped fiber, is being used. So when used, the draw of the Iridian doped fiber are produced, their gain profile will differ slightly. So necessitating to design the manufacture of the new GF. Optimization. So each replacement of the EDF offers an opportunity by this chance for the renovation. So new GFF are designed to meet the target gain profile to improve the system and save the cost by implementing the hybrid GFF technology. All right, so today's telecom filters in our company. So Iridian has a long history as the lead global supplier of the optical filters for the telecommunication industry, and provide the competitive price from the prototype to high volume manufacturing, leveraging our world-class design and manufacturing capability. We can consistently provide the best filters solution for your packaged component and modules. And our DWDM channel skip filter, multiband filter, hybrid GFF filter, and all other telecom filters are customer designed to meet all today's telecom system application requirements. So if you have any specific design and idea concept, just contact us. We can find a solution for you in most of chance.